Let's first of all consider what it means if A and B are mutually exclusive. So you need to know the words mutually exclusive mean they cannot happen at the same time. Turning this into a probability, this means the probability of A intersect B, so both things happening at the same time, is 0. It cannot happen. In part 2, A and B are independent. If we know they are independent, then we know the probability of both happening is just the probability of A times the probability of B. That simple formula is only true if they're independent. So let's go back to part A, part 1. We're trying to find the probability of A or B, A union B. We've been given the probability of A, we've been given the probability of B, and we know something about the intersection. So this means we should use the addition rule, which is given in the Edexcel formula book. So for part 1, this is 0.5 plus 0.3, but then take away 0 for part 1. A and B are mutually exclusive, so they cannot happen at the same time. So that is it, 0.5 plus 0.3, which is 0.8 for part 1. In part 2, we're told they are independent, so they could happen at the same time, and the chance of them happening at the same time is what we wrote up here. So the same thing, addition rule, A union B is A plus B minus intersection. So the probability of A is still 0.5. The probability of B is still 0.3. Doing the probability of A plus the probability of B counts the intersection twice. If you imagine a Venn diagram, if we colour in A and then colour in B, the middle bit has been coloured in twice. So that's why we're taking off one copy of it. We're not completely getting rid of the intersection. We're just accounting for the fact it was coloured in twice. In part 2, they're independent. So that means the probability of A intersect B is the product of A and B. So this gives us 0.65. In part B, starts with the words given that, so it might be a conditional probability question. Given that the union is 0.7, find the value of probability of B given A. Well, probability of B given A is the probability that both B and A happen over the probability of what was given, and in this question it was A that was given to us. Now please note that the probability of B intersect A is the same as the probability of A intersect B. They are the same. Doesn't matter which way around you write them. So this is what we want, probability of B given A. Looking at our fraction, at the moment we don't know the numerator, but we do know the the denominator is 0.5. So that tells us what we need to do next. We need to go ahead and find A intersect B, our numerator. Well, look at what we've been given. We've been given that the A union B probability is 0.7. In part B, we don't know if A and B are mutually exclusive or independent. We don't know. That's been left behind in part A. So let's put this into the addition rule formula. So A union B, which we know is 0.7, is the probability of A, which is still 0.5. That was true for the whole question. Plus the probability of B, which is 0.3, minus the thing we don't know, the probability of A and B. So it's this that we're trying to work out, and thankfully it's the only thing in the equation that we don't know, so we can rearrange and then we know what it is. So here it's 0.1. And now we're ready to answer the question. So the probability of B given A, the probability of B and A both happening, over the probability of A, which was 0.5, so that is 1/5, or 0.2.